So good morning to all of you. Myself, M. Rajan, Assistant Professor from Department of Agricultural Engineering at Sri Shanmuga College of Engineering and Technology. In previous lecture, we have seen the measurement of rainfall and its importance and types and benefits and what are the methods used to find out the measurement and units of the rainfall measurements. So these are the concepts we have seen in the previous lecture. So in today's lecture, and also we have seen the cages regarding a non-regarding type of cages we have seen in previous lecture. So in today's class, we're going to discuss about the measurement of evaporations and its process, how it's happening, and what are the uh, fact formula we're using, and how what are the instruments used to evaporations or the content we're going to see in today's lecture. Okay, we can move to next slide. So evaporation is the process by which water changes from liquid state to water vapor. It happened due to the solar energy and atmospheric conditions. So the major components of hydrological cycle and represents the loss of water from open water bodies, soil and vegetations. So the importance to measuring the evaporation is to determine the water loss from the reservoir, lakes and canals. Then to helps in irrigation scheduling and crop watering equipment estimation. So it assists in reservoir and watershed management. So supports hydrological and climatical studies. And evaporation is essential for water balance analysis. So these are the importance of the evaporation. So units to measure the evaporations are millimeter per day and millimeter per month. So both can be used to measuring the evaporation, or these are the units of the measurement. Okay, a measurement of the evaporation. So millimeter per in previous class that we seen the rainfall units that are millimeter per then centimeter in depth of the rainfall. But in evaporation case, we using the units of measurement that is millimeter per day and millimeter per month. Okay. So the some factors that affecting the evaporation are solar radiation, air temperature, relative humidity, wind speed, atmospheric pressure, water quality. So these are the some several meteorological environmental factors that affecting the how much of evaporation can be done in that area. So solar radiation means it's a solar radiation is the primary source of energy for evaporation. So higher solar radiation increases the evaporation. If the solar radiation is less in that area, then evaporation will decrease. So air temperature, the temperature in the air, that means high temperature increases the rate of evaporation. Okay. High temperature also participate in the evaporation process that influence the evaporation. So the relative humidity, low humidity promotes evaporation and high humidity reduces the evaporation. Okay, so if the atmospheric low relative humidity is very less, I mean low humidity promotes the evaporation. If the already there is high humidity in that atmosphere, that reduces the evaporation. So then the next thing is the wind speed. So wind removes the moist air from the water surface. So higher wind speed increases the evaporation. So as wind speed increase, speed of the wind is proportional to the evaporation. If the wind speed is increases, the evaporation will increases. Then next is the atmospheric pressure. So the lower atmospheric pressure generally increases the atmospheric evaporation. Then water quality, saline water evaporates slightly slower than the fresh water. So fresh water is rapidly agitate the evaporation process than the saline water. Again, so solar radiation, air temperature, relative humidity, wind speed, and atmospheric pressure, water quality. Wise. So based on these things, how the evaporation is affected. Okay, these are the factors that involve in evaporation process. Okay, we can move to next slide. So here the methods of measuring evaporations. First one is the glass A pan evaporimeter, then ASI pan evaporimeter, Colorado sunken pan lysimeter. So these are the different methods or instruments used to measure the evaporation. The first one is that developed by the World Meteorological Organization or recommended by the Meteorological Organization, that is WMO. It's a mostly widely used instrument, that is the Class A pan evaporimeter. That picture is given in the next slide. We can see. Then ISI pan evaporimeter. It is a Indian standard evaporation pan, commonly used in agricultural research active station. Then Colorado Suncan pan is installed below the ground level. Then class pan and then ISA pan is the installed above the ground level, but Colorado Suncan pan is the installed below the ground level. Then reduce the temperature effects and better representation natural condition. So the temperature effects and the natural condition will not affect the Colorado Suncan pan and its function. So lysimeter measures the evapotranspiration. It's important. It is the combined effect of evaporation and the plant transpiration. So that is the very important thing about the lysimeter. So used in crop water equipment studies. Uh, so here the table is given, the instrument with its applications. Class A pen, which is used in reservoir and irrigation. Then ISA pan is the agriculture research, and Florida pan is the natural surface studies, lysimeter in crop water use. So these are the important things about the instruments. I mean evaporimeter used in particular applications. Okay, so Class A pan is used in reservoir irrigation, scheduling, reservoir storage and irrigation scheduling purpose. We are using the Class A pan, and ISA pan is doing agriculture research stations for agriculture research purpose. Then Colorado pan is the natural surface studies. So there is no temperature and natural condition effects and factors affecting this type. So lysimeter is the combination of evaporation and then plant transpiration. So it is used in crop water use purpose. Okay. So class A pan evaporator is a widely used instrument evaporimeter to instrument the evaporation, that is recommended by the World Meteorological Department. So here the specification, I mean dimension of that uh, evaporimeter is given. The diameter should be the that is in the here in picture, that is given the centimeter. Then in meter it should be 1.21 meter. Then depth should be to 25 centimeter. Then it should be made of galvanized iron or stainless steel. Galvanized iron or stainless steel. Then it's installed on wooden platform about the 15 meter above the ground. So yes, it is the wooden platform which is higher about 15 centimeter from the ground surface. 15 centimeter ground surface. The depth of the galvanized C iron or steel is should be 25 centimeter. So then diameter should be 1.21 meter or 120.7 centimeter. So it is in the centimeter unit, then it is in the meter unit. Okay, so working principle. First we have to fill the pan with water to fixed reference level. That might be here or somewhere water, somewhere in that depth. So measure the water level every 24 hours and add the water to restore the original level. Then quantity of water added to equals to the evaporation. So after correcting the rainfall, we are adding the water to equalize the evaporation. So evaporation calculation is the formula, evaporation in meters of water added and rainfall correction. Then it is a simple and economical method, instrument, easy to operate and maintain, provides a reliable evaporation data. So that are the advantages of the class A pan evaporimeter. Then limitation, this condition, pan condition differs from the natural water bodies, and it requires a pan coefficient to estimate the actual evaporation. So we have to obtain the pan coefficient, then only I give the actual evaporation in this method, class A pan evaporimeter. So pan coefficient is Kp. The pan since the evaporation from the pan differs from the natural water bodies, so a correction factor is called as the correction factor. The is called pan coefficient. So the actual evaporation is the Kp, I mean correction factor into pan evaporation. Pan evaporation formula is also given in the previous slide. That is, evaporation is the water error minus the correction factor. Then Kp is the pan coefficient that values typically ranging from 0.6 to 0.8 dimension. It don't have any unit. That means it's dimensionless. 0.6 to 0.8 the pan coefficient values. The pan evaporation measured from the evaporation from the pan. So the application of evaporation data are used in irrigation settling, reservoir operation, water resource planning, and hydrological modeling, and drought assessment, and climate change studies. So for these purposes, we are using the evaporation data. Okay. So you should remember that the formula for evaporation uh, and then actual evaporation. So actual evaporation equal to coefficient of, I mean pan coefficient Kp into pan evaporation. Pan evaporation is measured from the evaporation from the pan. Okay. Okay, thank you. You here the right side, you can see that realistic view of that pan coefficient with anemometer. Okay. Okay, I hope you understood the today concept about the measurement of the evaporation. So, and its instruments used for measuring the evaporation. Then its applications. Other some things we are contents we have seen in the today's lecture. I hope you understood the today's concepts. Okay, thank you.